delighted to welcome Naomi Martin here to speak to you this afternoon. I had the pleasure of hearing Naomi speak for the first time at a STEM day that we had last year with some teachers that are working on a project with us, and I was very impressed with what she had to share. So I suggested to Judy we invite Naomi along to share with you guys today. To give you a little bit of background about Naomi, her parents are both maths teachers, so we won't hold that against her. But what Naomi has found is that the work that she does, there's a lot of foundation that she uses her maths for in that work. So Naomi works at the Sydney Opera House. She's the environmental sustainability manager, and she's been working there for 6 years. She's been working in the environmental area for 12 years, in lots of different areas and lots of different countries, but most recently at the Opera House. And she's going to talk to us today about some of the projects that she's been working on at the Opera House and show us how maths has influenced and been a part of the projects that she's been working on there. So I'll hand over to Naomi now.
Well, hi everyone. I'm actually going to start off with a short video about how sustainability is part of the heritage of the Opera House, because it's not necessarily obvious how they should link together initially. Can you hear that?
Hello, I'm Teddy Tabu-Rowe. We're here inside a building which represents a masterpiece of human creative genius. What is lesser known is there is a sustainability story to Unison's legacy. Let's hear from students, staff, and specialists of the Sydney Opera House. Unisson was inspired by nature, its forms, functions, and colours. He referred to birds' wings, clouds, shadows, walnuts, rivers, palm leaves, and nature's colours.
What a lot of architects do is look at nature and translate it quite literally. Utzon was different. Utzon was able to look at the systems that underpin nature and transform them into something else. He was really fascinated by birds and by fish and by plants and all these things that nature over time had refined to such perfection that they kind of encapsulated the ultimate efficiency. So to Utzon, efficiency was beauty.
He was inspired by the natural setting. He spoke of headlands, the harbour, and of sunlight.
What's really inspiring to me was his ability to achieve his architectural intent, to have a building that is sculptural, to have a building that is inspired by nature, and to have a building that plays with light.
He was a pioneer of the prefabrication and of this kind of modular and systemic way of building and allowing a building to kind of grow out of the ground.
One of the major things that strikes me about Jorgensen and his design principles was the idea that we should always understand the sites that we're working on, understanding what's around us to make it sustainable, to make not so much of a huge impact, but just the right impact.
Today, many of Utzon's design principles could be thought of as sustainable design.
Normally we would design a building for a 50-year design life. For the Opera House, the choice was 250 years. The Opera House adopted a philosophy of not using a lot of cladding material on it. There was a lot of use of concrete as an exposed element.
Right from the beginning, the Opera House implemented some really pioneering technology. For example, this water-efficient air conditioning system, which uses seawater to cool the building.
I think what's really inspiring about the Opera House is that it's a project that was truly courageous at the time. It had to tackle technical challenges that have never been tackled before. It shows you that nothing is impossible, nothing is unsolvable.
What is sustainable design? I think before we can call anything sustainable. It has to be really, really good at what it does.
Woodson really understood the basic elements of humanity and what it is that we need in buildings, and was able to construct something that will not only last because of its material properties, but also because of the way it communicates to us as a public.
We can all learn from Woodson's sustainability legacy.
Absolutely, sustainability is relevant for Sydney Opera House today. It's part of our history, and it's part of this building. I think it's also part of the legacy that we leave for future generations of artists and audiences and visitors.
So that's just a short background. The Woodston was inspired by nature, and sustainability is part of the Opera House. Now let's see if we can see. Right. So I'm an environmental scientist. I actually started studying medicine and was really miserable, and so I decided that I'd study what I loved, and what I loved was camping. So I studied environmental science. I then went to work at the EPA, and obviously spurned the life of a maths teacher. Said, I'm not going to be like my parents. But the interesting thing was that I find that I keep on coming back to them and getting them to check my spreadsheets. because actually what I'm doing is I am actually underpinning a lot of what I do in terms of managing energy and water and waste, and providing data on sort of audience engagement is about maths, and it's about spreadsheets. So this is just a little one, and this isn't something that I made up. This is on the web, so it's something that's common to a lot of environmental scientists, and find that we are actually doing a lot of maths in our job. So why would an environmental scientist be talking to a group of maths teachers? So I've tried to summarise in this slide a little bit about what I do, what the Opera House does, what I think you do, and students. So in terms of the Opera House, first of all, there's a sustainability program looking at being resource efficient, in particular energy, water and waste, and making sure that we save resources and money at the same time. We also have a objective to engage and inspire. We also have an educational creative learning program. I'm just going to invite Bridget Van Leuven, who's the head of creative learning, to briefly outline what that is.
I don't have parents who are maths teachers. I wish I did, because I get my budgets checked. But my name's Bridget. I have a great job. I'm the head of creative learning and families. So my responsibility is to look after the cultural program at the Opera House. In our creative learning program we have is for K-12. I know you're all secondary teachers, but we engage with about 30,000 kids on site, and about 7,000 digitally across the country. In terms of sustainability, we would choose a production from Korea
you story number one, concert hall lights. We recently upgraded the concert hall lights, and I'm just going to show you a little video that was on ABC News about it. And what I'd like you to do is there's lots of numbers through the report. I'd like you to just write down what those numbers are, and then we're going to talk about them afterwards. So if everyone's got their pens out and ready. All right, you guys ready? Here we go.
The Sydney Opera House is lining up in a very different way, with projects that's slashing power bills by 75%. For the first time, the concert hall's been transformed with LED lamps that are specially designed to complement the building's heritage status. Nicole Shepard went behind the scenes for an exclusive look at the technology that's providing spectacular displays both on and off the stage.
If you go down to the Opera House, you're sure of a big surprise. Hundreds of lights have been replaced with custom-made LED lamps in an upgrade that's taken 2 years.
We want the audience to feel that this is an incredibly special occasion for them, and that environment that we can create with the lighting is a very important part of that.
Changing lights in the cramped roof space of the iconic Opera House sails was a difficult job. The new technology's made that job a lot easier. It's also slashed power bills by $70,000 a year, removed 4 tonnes of air conditioning ducting from the roof cavity, and drastically reduced the need for maintenance.
I think there's 355 fixtures up there. We were doing those probably on average 5 times a year for each fixture. We're now doing that once every 9 years.
Each light can be customised to produce a traditional effect for the Sydney Symphony Orchestra or rainbow bright for other concerts, and that will benefit not only the big stars but less well-known performers too.
School children, 7 and 8 year olds playing recorders and singing in choirs, through to our contemporary music program. We're not trying to turn it into a disco, we're not trying to turn it into a nightclub, but we can if we want to.
Sustainability Award for improving the efficiency of a heritage building.
The concert hall upgrade is also shining a light on the environment, slashing 450 tonnes of greenhouse gas emissions every year in a project that should pay for itself within 6 years. Nicole Gentle, ABC News, Sydney.
Alright, so we're just going to be making cheap chocolate thrower. I've got some chocolates left over from an event I had the other day and want to get rid of them. So anyone who yells out a number they heard gets a chocolate. 75%.
4 tons of air conditioning ducts. $70,000 a year.
Yeah, I'm a cultural person.
It's
Not
actually
a
$75,000 a year, Eddie, I had to correct it.
I think there's some up there.
Oh, yes, the something
You guys are obviously very good listeners. So just to let you know that all those numbers came for a simple Excel spreadsheet, and it's just something that you guys classroom that, you know how, yeah, obviously here there's 2 tubes in each fixture. So you know, we'd have 2 fluorescent tubes. And imagine there was 8 fixtures in each tube, and each tube, like a T8 would average, on average, draw 45 watts. In total, if you had 2 tubes in 8 fixtures at 45, what's the total power? Chocolate for the first one, who answered the question? No shooting. Yeah. What's it?
Oh my god, that's so easy.
Alright, so the hours used. Just say the lights are on 12 days a day, hours a day, 5 days a week, 40 weeks per year. How much time are they on? No.
What they'll do for a chocolate.
Sorry. Yeah.
There's nothing wrong with extrinsic motivation.
So energy is actually, it's a really simple calculation. It's just power or watts times time. So the power was 720 and the watts, the hours was 2,400.
1,500.
I can't remember what it is.
I was like
720 times 240 divided. So what's the energy you think kilowatt hour? So kilowatt hour. Was that, you said 1,000?
Yeah.
Oh yeah, next one. You too quick. Excellent. So again, this is something that you can do with your kids. You can work out what you're using now, and then, for example, if you then change, there's now LED tubes you can get that fit straight in where the old fluorescent lights were, and you can also put motion sensors quite easily at the same time. So you'll go from using 45 watts to 20 watts. The total power will reduce, and so you can do very simple spreadsheets using the calculations you just did to work out the energy that you can save and the cost saving too. So, and again, I'm happy to share this spreadsheet on
So
Dropbox.
did you say you can get an LED tube that just fits straight in?
Yeah.
It's not a new fitting, it's just...
No, so you do change, some of them you have to change the ballast, which is the kind of connection point, but they're essentially designed so you just swap them over. Yeah, so it's, which is really, you know, and they're not necessarily, they cost a bit more, but the lifespan is also a lot longer. There's 50,000 rather than, you know. Yeah, so, and actually you're probably not you're only going to save 364 per classroom, but if you put it over the whole, you know, school, and then you can, there's often grants around for supporting those families as well. So yeah, you can have a good payback as well as a learning experience for kids. So sustainability story number 2, carbon and events. So carbon is something, you know, making events carbon neutral and trying to reduce the carbon and impact of events is something that's been of interest right around the world. For example, there's a Swedish music festival which has gone veggie for the 3rd year in a row. Sydney Opera House has got Morrissey coming for Our Vivid Live, which is coming up in June. And for 3 days, the Opera House is going vegetarian on his request. So, and that's not for carbon reasons, but for animal rights reasons. But very interesting as well. It's just something that's important to performers, also interesting for audiences as well. So carbon, I'm going to do a bit of a detour here and talk a little bit about carbon. It's something that's I'm passionate about, and it's something that I think is misunderstood because people don't understand the maths. And so I'm going to do a bit of a maths carbon 101, and I'm going to start with a fun video.
The Earth. You may know it as that blue thing Bruce Willis is always trying to say. Or from his famous collaboration with wind and fire. Anyway, the Earth had some genuinely bad news this week.
A White House report that says global warming threatens every part of the U.S.
This isn't something in the distant future. Climate change is already affecting us now.
Now. Smart move, Obama. That is a key shift in how to talk about climate change, because we've all proven that we cannot be trusted with the future tense. We've been repeatedly asked, don't you want to leave a better Earth for your grandchildren? And we've all collectively responded, yeah, fuck them. Incredibly, this latest damning scientific report may still face an uphill climb with some of us.
There's that Gallup poll that came out last month, which found 1 in 4 Americans
gives a shit? That doesn't matter. You don't need people's opinions on a fact. You might as well have a poll asking which number is bigger, 15 or 5. Or do owls exist? Or are there hats? The debate on climate change should not be whether or not it exists, it's what we should do about it. There is a mountain of research on this topic. Global temperatures are rising, heat waves are becoming more common, sea surface temperatures are also rising, glaciers are melting, and of course no climate report is complete without the obligatory photo of a polar bear balancing on a piece of ice. But the only accurate way to report that 1 out of 4 Americans are sceptical of global warming is to say a poll finds that 1 out of 4 Americans are wrong about something. Because a survey of thousands of scientific papers that took a position on climate change found that 97% endorsed the position that humans are causing global warming. And I think I know why people still think this issue is open to debate, because on TV it is. And it's always one person for, one person against. And it's usually the same person for.
Bill Nye and Marshall Blackburn, welcome both of you to Meet the Press.
Bill Nye joins us now, along with climate change skeptic Mark Moran.
Joining me now to go head-to-head, Bill Nye, science educator, the CEO of the Planetary Society.
In the crossfire, Bill Nye, the science guy. Bill Nye, the science guy who believes in man-made global warming.
Yeah, that's right. More often than not, it's Bill Nye, the science guy, versus some dude. And when you look at the screen, it's 50-50, which is inherently misleading. If there has to be a debate about the reality of climate change, and there doesn't, then there is only one mathematically fair way to do it.
Last Week Tonight presents a statistically representative climate change debate.
Good evening. Joining me tonight, a climate change denier and naturally Bill Nye science guy.
Humans are causing climate change?
No question. Wait. Before we begin, in the interest of mathematical balance, I'm going to bring out 2 people who agree with you, climate skeptic, and Bill Nye, I'm also going to bring out 96 other scientists. It's a little
So you get the picture. So let's talk about some of the science. There's a place down in Tasmania called Cape Grim, and it's been chosen because it's one of the places on Earth with the most clean air on the Earth. And for every year since around 1975, they've been getting a bottle, and they've been putting air inside it and just capturing it and keeping it for posterity. And they measure different elements in the air and different pollutants, and they also measure carbon dioxide. Misleading graphs.
Yes.
And so this, what's misleading about it?
Oh, just in maths, which is
It's meant to start on 0?
should start at 0.
Okay. Well, there should be a little squiggly thing in between there. This is from the CSIRO. This is
That's what the climate skeptics are going to say.
They won't ignore this class.
So except for the fact that it could be going a really long way down to 0, this shows that over the 39 years they've been measuring that the CO2 has gone up by 65.91 parts per million. So you say carbon dioxide parts per million, that's tiny. What does that matter? But CO2, so that means that CO2 at the moment at 390 parts per million is about 0.39% of the atmosphere. But there's some things called trace elements which make a big difference. For example, another trace element which makes a big difference is alcohol in the blood. 0.05% alcohol blood limit. Obviously, there's a reason why there's a 0.05% alcohol limit, because it's something that can make a big difference to the system. And carbon dioxide is the same. It's one of the reasons why the Earth is habitable. It's also one of the things that can change the atmosphere and the climate on Earth significantly. So one of the things it does is increase temperature. There's a really cool thing on that the IPCC put out where you can put in your year of birth. And scarily, I worked out how old a 15-year-old, when a 15-year-old would have been born. Like, it's the year 2000, which makes me feel quite old. So if you enter the year of birth, it's 2000 in this website, and temperatures increase in your life so far, and also the future, depending on how we react to climate change and how much we reduce our carbon emissions, how much it's going to increase in the future. So that's an interesting thing that you can do for the kids to make it real for them. There's been a whole lot of science that's come out that's more and more certain about the types of impacts that are going to happen. There's been a recent, at the end of 2014, there was a study called out the Climate Change Snapshot for Sydney, talking about what's going to happen. And it's talking about by 20, the maximum minimum ranges of what the average temperature could increase by. There'll be more extreme temperatures, there'll be less annual rainfall but more severe storms, and there'll be sea level rise in the next sort of 50 years of between 0.15 to 0.4 metres, essentially going up about 1 centimetre a year around Sydney. So,
Your office on the ground floor of the upper house.
Yeah. Actually, I'm on the second level at the moment, so it's alright. Alright, so can everyone read this? I wasn't sure how this would come out. Yeah. So this has got some data about globally what's the impact of of climate change and the amount of carbon we're going to put in the atmosphere. So we're at 395 parts per million, which is around 400 parts per million is considered the safe limit for 2 degrees warming. Then sort of 3 to 4 degrees goes higher. And just looking at this, I'd like you to speak to the people next to you and just have a discussion, looking at these predicted impacts and the ones for Sydney as well, which is hotter, longer periods of heat, higher maximum temperatures, less rain but more severe storms and sea level rise, plus this data here. I want you to just have a chat within yourselves for 2 minutes about how could it impact you, Sydney and Australia, climate change in future. Now, can anyone yell out an impact that they can see from the data that they've seen?
Less corn.
Higher food prices. Chocolate will get more expensive too.
Yeah.
Actually, it's a chocolate shortage.
Yes. No, that's
Nutella shortage.
less child slaves.
Any other ideas of things that how it might impact you personally, climate change?
No.
Pardon? Sorry? Harm before sure will change? Oh gosh, sorry. Anyway, that was a parabola. Any other feeling for how it might impact you personally?
I don't like heat.
Yeah, exactly. And lots of people don't like heat. In the Melbourne fires, the Black Saturday fires, more people died of heat than they did from fire during that time, during that heat wave.
Coastal erosion's really bad too.
Yeah. Excellent. All right. Well, thanks very much. That was a really interesting idea about how it might impact on you. So thinking about how it might impact on Opera House, it can impact on businesses too. For example, we have events that are held outside, not necessarily the Australian Open, where Australian Open had that series of 45-degree days, but that could easily happen on a day that we hold a triathlon or a sort of end of a marathon, and with catastrophic consequences or really dire consequences for people who are there. The droughts can lead to dust storms like we've seen before. Sea level rise, the sea level rise pictures where you have water coming up 60 metres isn't what's predicted, but these pictures that you can see on the side there were actually taken during a king tide, which is the kind of the levels that are predicted for sea level rise in the next 50 years. So, and those ones are starting to splash over, and so it'll have infrastructure implications for people on the foreshore, like you said. More severe storms can have big implications for outdoor events, and heat waves. It's going to be very hard for tourists to be walking across the forecourt when you're without any trees, which is what Nixon wanted when it's 45 degrees. So there's implications for our business and for for our personal lives and our businesses from climate change. So the third point in Carbon 101 is that you can make a difference by understanding carbon emissions. And when they say a carbon footprint of an organisation or a carbon footprint of a house is such and such, it's not that they've put a big bag over the house and they've just measured how much carbon comes out and then collected it all and then measured it. What they do is they know that emission factor, and you just, to work out the carbon you're emitting, you just say how much electricity you use, times it by the emission factor, and you've got your carbon. You can do also unleaded petrol, you can also do, but you can also do things which are sort of indirect emissions, but it's part of our life. For example, flights, you can do the kilograms per kilometres per person. There's calculations that are sort of accepted by government in terms of calculations of carbon emissions. You can also do the life cycle of food as well. BPA Victoria has some emissions you can use for that for standard food. So by doing that, you can have a picture of what part of your activity, whether it's all of Australia, which is the bottom right-hand graph, or a typical household, which is the top graph, how their life produces carbon. So carbon 101 summary, that big detour was CO2 is increasing as per the graph that wasn't mathematically correct. Continuing to increase CO2 atmosphere does have impacts that we would most likely like to avoid, and by understanding carbon emissions, you can make a difference. So back to sustainability story. Vivid Live carbon footprint. So 2 years in a row we've done a carbon footprint, and for Vivid Live, which is brings out performers from international performers, as well as having lights on the Opera House in May and June. The electricity is flights is obviously the biggest part of our carbon footprint for Vivid. Electricity is next, but interestingly, catering is up there as well, which is something that we weren't expecting. So in terms of looking at what we can do to make a difference in reducing the carbon footprint of Vivid is, we could have more local artists. We could have reduced electricity, which is sometimes hard to do, and another place where there's big wins is catering. So we could look at what we're feeding people. And again, this is from a calculator, just to observe that this is by teaching your kids how to use Excel spreadsheets. It's going to set them up for a lot of different jobs. So, I do encourage you to teach using Excel spreadsheets. So for example, from that Excel spreadsheet where you plug in all the information about how much electricity and food and different types of food and waste, etc. This is one example from Vivid 2012. Band number 1, which is Janelle Monet, for their rider, which is the food they have in their dressing rooms, requested 400 chicken wings. So 400 chicken wings, when you times it by the emission factors from the EPA, is 4 tonnes of carbon, which is more carbon than was around the amount of carbon as an average car for 1 year. So when you look at the embodied emissions in 400 chicken wings, it's about the same as a car. Band 2, which is temperature, instead shows a platter of fruit and vegetarian sandwiches. And so that was about the same as half a scooter for over 1 year, or 1 tonne of carbon. So it shows that you can make active choices, particularly around the things we consume, not just the fuel and the energy we use, so that can make a difference to the carbon in the atmosphere. So at school, you could do the same thing. You could look at the ways that you guys could, the school kids could reduce the carbon they emit. And maths, again, with these emission factors, gives you the tools to work out how much you could reduce. For example, here's an example of just some small calculations of electricity for a 4-person home, a car for 1 year, return flight to Melbourne, cutting down 1 serve of red meat. Just talk within yourselves, like, what's something, looking at those examples of the carbon emissions, or don't even talk about, shout out some ideas about what you could do to reduce carbon.
No vegetarian.
Yeah. Sorry. I'll do underarm. What else?
Turn lights off when you go.
Yeah. Yep. Anyone at the back want a chocolate?
Anyone up the back away?
No. They're just afraid that I'm going to hit them with the chocolates, I think. So basically that's just in summary that at school you can also use these examples of maths in sustainability in terms of energy or carbon. There's also lots of other examples in terms of waste. You can do waste audits, you can do water, calculating the water that would run off a roof and how big your water tank would have to be, your rainwater tank would have to be. There's lots of different examples where you can use maths to excite kids and actually, find out information that, about how you can make a difference. So sustainability over. Sydney Opera House on the map.
hexagons.
I heard that it's German. Parallel lines. Yeah. Hexagon, yeah. Who's hexagon? Who said hexagon? Oh, cool. Excellent. Cool. No worries. So yeah, these are some of the ones that I found when I was looking. And you guys have found a lot as well, which is great. But did anyone see a sphere? Did you know that
I was saying sphere, but I didn't know it was allowed to be said yet.
You can't see it yet.
So, all the sails at the Sydney Opera House are actually from one sphere. So originally, the original designs in the top left from the Utzon's design that won the competitions in the top left, and that was actually an elliptical shape to start off with. And then it went through lots of designs. Basically, they didn't know how to build it. They didn't have computers. They didn't have, and so for these irregular shapes, they didn't know how to model the forces. So they were really struggling a lot to how they were going to do that. But eventually they came up with a spherical solution. So what I'd like you to do is get 4 volunteers to make the spherical solution. We've got some Play-Doh, sit up the front. Can 4 people come down and get lots of chocolate? So when you come down, I'll read what Jonathan said